Do you want that to be AWS? Hmm.
It can be multi-cloud, so if you feel
Yeah.
it.
Let's do Azure to keep everybody surprised. And then if you think you need AWS, you can join next time. Hmm. All right. So you want me to take over already?
I think yes. Let's go straight into
Perfect.
the fun part.
All right. So good evening, everybody. My name's Clemens, and I'm a platform architect at Humanitec, as not Christoph, but Antonello, who's incognito, has already said. Um, and I'll be, your technical tour guide today. As I learned, I'll be doing not AWS. Um, the sound is closed, so you cannot unmute yourself and speak up. But what you can do is you can open the chat and put stuff in there. So for the housekeeping part, if you have any questions, feel free to put them into the Q&A tool, or possibly into the chat. Q&A tool is probably going to be gone through at the end. And let's see. If I can pick up any questions, I'll try to weave them into the demo. Speaking of the demo, without further ado, I'll be sharing my screen any second now, and then we'll kick it off. I decided this to be also no slide Monday, so I won't be shooting any marketing material at you. Instead, I will try to see how far I can get with our own documentation and some hopefully meaningful explanations. And obviously, we'll deploy stuff and provision stuff and have some fun because that's what an orchestrator is all about. Right. Let's see if I can share my screen. And put you guys on my second screen. All right. Oh, so can you guys see my screen? I hope at least Antonello will be nodding furiously now. Yeah, perfect. Okay, great. One thing up front, for everybody that doesn't know yet what a platform orchestrator is about, let's put up a quick definition of what an orchestrator actually does. Without going into the additional features or added value, a platform orchestrator is basically a combination of the thing or the things that deploy your application and the things that provision your infrastructure. If you roll that into one domain, you are able to provision a landing zone for your deployable and then configure that deployable according to the landing zone you just created and deploy that correctly configured deployable and have one consistent whole thing. And Antonello is raising his hand. I can see that. So are you
Sorry, it was
doing
a
it?
mistake.
Okay, great. That is what an orchestrator does. It is not just the deployment, it is not just the provisioning, but both things rolled into one. And if you're building an internal developer platform or short an IDP, then you probably want to have an orchestrator as one of your components because that helps you to have all of the integration of those two domains and all of the surrounding tools in one place. And you don't need to faff around and find out how you can make this work in any other way. So that's what an orchestrator does. And yeah, the Humanitec one, at least the documentation for our orchestrator V2 lives under developer.humanitec.com and then the V2 documentation. And if you start on the overview here, then you'll be greeted with this lovely picture, which basically tries to explain on a very rough level how that thing works. Well, as you can see, You have a few entities that make up the configuration and the main domain of the orchestrator. Then you have the deployments. They are coming from developers, platform engineers have configured the orchestrator. And that leads to the fact that if you launch something in your own infrastructure, then you get workloads and resources. So resources, infrastructure, workloads, deployables, and all of that rolled into one. That is a very good question, James, because these kind of things are not on the picture, right? Um, and the answer is both. Yeah. It can definitely work together with Argo if you want to have something like a GitOps workflow, or it can replace it, yeah, and deploy on its own. Both scenarios are possible. It actually depends on your requirements and your existing flow and your desired outcomes. What is the most feasible way for you to go on with your platform build? But before we dive into more such very specific questions, let's stay on the generic domain for a second, right? Before we go into the technicalities. So that is the very rough overview. And then we can dive a little bit deeper into the object system of the orchestrator to understand what is in there and how it clicks together before we see it working for the first time. And for that, I'm going to steal a little bit from my own documentation under tutorials, first deployment here. And that part is a little bit hidden after a lot of prerequisites, the first few things, and I think I scrolled over it. There it is, orchestrator object landscape. If you click on that and you open that up, you get the object landscape of the orchestrator, all of the objects that are in there that make the system tick. So we start on a project, and a project is basically a binder for environments. Yeah. So contains 0 to as many as you like environments, and environments can be of a type. Think development environment, production environment, or any other taxonomy that makes sense for you, like EMEA environment, US environment, APEC environment. Yeah, could be anything. Typization is mainly later used to select a specific environment according to its type, or a lot of environments according to their type. Environments contain deployments. Yeah, that is what happens. A deployment and a deployment is created by a so-called deployment manifest. Is this platform open source? No. Simple answer. We utilize open source where it makes sense. For example, when it comes to SCORE, which is a platform agnostic and environment agnostic workload specification that is stewarded by the CNCF. Yeah. We use these kind of open source projects where they make sense. But the orchestrator itself is closed source. And it is not a platform, but it is a platform component. That is important when you have a mental model of what it is that you're going to get in the end. Yeah? If you're building a platform, you need many components. Because you need all of the things that make up the software development lifecycle for your developers. Yeah, you would, for example, never consider building out a platform that does not have support for version control. So some kind of a repository, Git repository most possibly, is part of your platform build. Yeah. And you have many more components that make up your platform in the end. An orchestrator would be one of them. Let's see if a tea can help with that without me burning my tongue this time. Yay. So a deployment is created by a deployment manifest. And that actually leads to the fact that part of this deployment are so-called active resources. Active resources represent actual infrastructure, so databases, message brokers, DNS records, but also more abstract things like firewall rules, user accounts. Yeah, you name it, we have it. Whatever needs to be put into place to make your actual deployment land on that infrastructure is modeled by an active resource that represents actual infrastructure. They are also of a type, yeah, and the deployment manifest uses those types most of the time to request the infrastructure. Um, and if you think back to, haha, I tricked myself, to this picture here, then you probably remember that over here was Terraform and OpenTofu, which is like the daily driver for the orchestrator, the language in that the platform engineer specifies what infrastructure needs to be provisioned. And, or sorry, how infrastructure needs to be provisioned. And that is the reason why active resources are created by modules, akin to Terraform modules. They use Terraform providers to actually create those actual infrastructure instances, and all of that is happening on top of a runner. Yeah, so much, so easy, hopefully. Because most of these things, if you have used any kind of Terraform to create a little bit of infrastructure, should be falling into place language-wise quite naturally. And we hope we have hit the rest of the terms equally well. If anything sounds super strange to you and you think, hey, why is it not named like this? Please let me know in the chat, right? Okay, so, but that is the object landscape that we'll be going through and using to create some stuff. TM. Okay, so to do that, we first need to have a starting point so we can have some fun together. And I have prepared the least complex setup to start something possible. So no front end portal that has a scaffolder, no scaffolding framework like Cookie Cutter, but a good old GitHub template repo that I can simply utilize by clicking on this button and starting a new project or product in this case. Going to make this public, JTest 101 it's going to be. Let's create that repo and get ourselves a starting point. Part of that starting point is obviously some code. That code is going to be built into something by a Docker file with some GitHub action-based pipelines. And then we will have a Helm chart that is actually deploying these things onto a Kubernetes cluster. But for that to work, we do need some additional infrastructure. And to get that, we end up with this deployment manifest YAML here. So all of the rest, I'm not going to step through that in detail now, but we're going to look at the deployment manifest first of all. Antonello, is that large enough to be readable, or do I need to zoom in a little bit?
Yeah, zoom a little bit will help.
All right. Better? Perfect.
Way better.
It's like, I don't need anything to read that now. It's like huge. Great. So what do we see here? A simple YAML-based format that is built to enable the developer to request infrastructure and with a very clear purpose to do that on a very high abstraction level. So this here only conveys the what. Yeah. For example, I'm asking for a bucket here. That is probably going to be an S3 compatible bucket. Yeah, and so you can see that the level of abstraction is also adjustable. I'm asking for a Kate service account and a Kate's namespace here. I could make them go away and not be needed inside of this file, but I'll be showing you a little bit later how that is actually coming to pass. Yeah, for the first round, we have them here. So you can see the level of abstraction is also adjustable. So, and if I'm asking for a bucket, I somehow need to connect this bucket to my application that's being deployed. And for that, I do have the bucket name down here. And I use this placeholder language to select from all of my resources the one called bucket, take the output, the name, and put it into this output. And that leads to the fact that when the provisioning has been executed and those outputs are presented back, they can be used as variable file to be joined with the Helm chart that is being deployed. And as such, the application that is being deployed is now configured to connect to the freshly provisioned infrastructure. And everything comes together naturally. So hopefully I've been talking for long enough that this has actually happened in the background. Yeah. Depends a little bit on how far we are. The scaffolding has happened and the release is also probably happened, at least far enough. Hello, GitHub. I would expect some steps to appear here. Ah, there we go. And this is exactly the right one. Wait for service and show URL. As soon as I have that, I can show you the deployed outcome. Ah, here we go. Stop scrolling. Okay, so right behind that IP, there is our lovely demo application, which is a very gray screen that presents us with the just provisioned demo bucket's name. Yeah, so not the most flashy demo application. Next one will be a little bit more flashy, but it demonstrates that we can connect to just provisioned infrastructure. And obviously, you can see that I've prepared a little bit more. I've been simulating doing a development iteration in the background, and I have all the code in place to also connect to a queue. But the queue name is unspecified, so I can't connect to a queue right now. I'm lacking the needed infrastructure. So let's see what I, as a developer, need to do to get that queue. So back to GitHub. I'm going to literally stay in GitHub and do this in here because it is so simple to do that I don't need to check this out and go into an IDE for it. So just pushing the button here. And I do want to have a queue. What is a good name for a queue? What about Isabella? Isabella the queue. Um, and obviously, I need to have a queue name. I know that because I specified my application to need this in the queue name. So from the resources, I take Isabella, and from there, the outputs and her name. And that's what's going in here, coming from there, and hopefully leads to the fact that now my application will get a bucket and also a queue and can connect to both. So committing those changes while Copilot is thinking, I'll try to be my work self, and I'm not committing directly to the main branch. I'm creating a new branch for this commit, and I'll start a pull request. So, and while this pull request is running, because we can't do something right away, yeah, merge is going to be deactivated any second, and there's going to be some checks running. While that is running, we can take a look over here at the orchestrator and find out how the outcomes are actually showing. So going in here, I do have a default environment, and in here I can see the resource graph for the first time. So that's what the deployment manifest has become. Everything that the orchestrator knows about my deployment, and also my application architecture come to life basically. So here's the Kubernetes service account, the namespace. I can see the dependencies, how they flow here, and also my bucket. Yeah, as I'm not doing the deployment itself or have more complex infrastructure, that is not the most interesting resource graph, but it is one. Yeah, as you can imagine, these things can become quite complex very quickly if you have a lot of security or other things baked into this. So that's what my deployment is all about, how it's looking like. And you will be able to see more information in the resource graph later down the road. For this example, I do not have any metadata attached. So if I click on the bucket here, for example, I can see, okay, this was created by this module here, GCS bucket. Didn't want to go there. quite yet. Trigger happy on the click. So GCS bucket, that's the module. And I do not see a lot of information because down here there is no meta information. As a platform engineer, I can decide what kind of information should be shown back to my developers. So a little bit later in the next example, you will see some metadata and how that looks like. Right. So, and let's take a look at the few things that you probably recognize from the object model. We are inside of a project. We are inside of the default environment. So in here, we see the active resource graph, which contains the active resources. And they have been created by modules, modules depicted here, and a specific version. And all of that has happened on top of a runner. Yeah, we'll take a look at that stuff later down the road. The main distinction for you guys to know probably is left-hand side orchestrator in SaaS version or in the self-hosted version. SaaS version, obviously, inside of the internet, hosted by us. Right-hand side runner, always in your infrastructure. Yeah. Okay. Right. So we'll see a little bit of that later down the road, Sean. Yeah, so I won't go into that one right now. Configuration link, or sorry, documentation link as already provided by Antonello. Yeah, if you're missing anything else, just let me know. So all of that has been provisioned, and probably I've been talking for long enough again, so that the rest of the provisioning has completed here as well. All checks have passed, so that is true. Let's take a look. One of the checks is once again a release step. And in here, I can find wait for service and show URL. Open that one up. And sure enough, this time we have Isabella with a very strange name. Second call demo topic and some crazy ID here. So we definitely have something very unique. Now, the thing is, if you've noticed already, that check step had a very suggestive name. It said, deploy to ephemeral environment. And that's the reason, if I take a look here at 34.159, whatever, that's the IP of the first deployment, I can reload this. Yeah. There's no queue in here. But over here, 34.89, so different URL, I have my queue here. So this is definitely a bespoke environment, an ephemeral one at that as well. Going back to the orchestrator and up to my project, I can see I now have two environments. One is the default environment and the other one is called ephemeral PR1. And in here, sure enough, I do have Isabella the queue. While in my default environment, there is nothing like it in there. So the reason why it makes so much sense to have these things is, to give you one use case, there could now be a long-running integration test set. Long-running, like an hour or two, I don't care, because if another developer comes around and wants to deploy his changes into the development system, he can do so. My change set, which needs to be stable applied to a system where the test set is running against, is running in an isolated environment and as such cannot be interrupted. So that is great. And the reason why I'm using this technique is simply because I can. It is so easy if I have all of my environment described in form of this deployment manifest, where I simply state like, look, this is how the configuration for my application needs to look like. And then the orchestrator can add the what, because that has been provided by the platform engineers beforehand, the configuration, which includes the what. The how, not the what. So this is the what here. And the platform engineers have specified the how. Yeah. And the orchestrator brings that together. And it allows me as a developer to self-serve this infrastructure and to self-serve environments, because that's all I need to know. Yeah, that saves a lot of cognitive load. That saves a lot of time. It shortens the process, and I don't need to wait on anybody else. And it allows the platform engineers to work on the how, also in an abstracted way, disconnected but not disjointed. Yeah, where they can prepare the next tile of the golden path that I, as a developer, am walking on, and can provide those new capabilities and those new versions. And with the next deployment, I can already get to them. Yeah. Right. So that is what has happened basically in the background and why it makes so much sense to have an orchestrator around. So I do have this ephemeral environment set up and I'm using it. Oop. So that's the one. So let's assume for a moment I've done a great job and I can go back to my pull request and actually mark this as completed. Yeah, leaving best practice land here, never merge your own pull request if you're not in a demo scenario. But I feel very confident, so I'm going to delete this branch and say, that's it. As a developer, I'm finished with this now. As a platform engineer, I'm slightly intimidated. Yeah. A robot created a ton of infrastructure, so who's going to tidy that up now? Well, the answer is obvious. It's obviously going to be the same robot. That's the reason why you see another yellow dot here in GitHub notation which says pending, because deleting that branch immediately kicked off another CI run, which is going to do two things for us. It is going to run a deployment over here. Let's refresh that and see, it's already running. And if I take a look at the deployments, I can see this one here, which is currently running, is running in destroy mode. Yeah, so when that has completed, the environment will be completely destructed, the infrastructure collected, and all resources freed. Um, then ephemeral PR1 will go away, and because I merged back to main, I have this default branch here, and then on the actual version that includes Isabella the queue. So I'm not going to stay here and wait for that. That's simply going to happen. And that's exactly how developers think about it, right? I can stay in my IDE, I can stay coding. Just committing my code into version control will kick off all of the processes and will kick off all of the right outcomes that I need to have. Yeah? I simply can keep coding and wait for the green or the red light that demarcates in my IDE if my test set was successful or not. Can stay focused on the job of coding and solving business problems. How would you integrate this deployment with the ServiceNow approval workflow? That is a nasty question. Um, because obviously approval workflows are a thing that makes a lot of sense, but in any kind of optimized development workflow, you want to stay away from them as far as you can, right? Every manual approval stop leads to the fact that you're stopping the developer dead in his tracks. Now he needs to wait on somebody to push a button, right? Um, so first of all, I would try from a workflow perspective to wrap only the needed environments into actual manual approvals. Or yeah, any things where there is a really there is an outcome that I absolutely need to document. Yeah. Hopefully, I can keep my developers very autonomous in their development environments. So no manual approval steps or ServiceNow workflows needed to self-serve infrastructure. But if I progress that into a higher stage, then most probably I would kick off an approval workflow. That could be connected not just to ServiceNow, but also to other systems that lend good information to approvers. For example, a FinOps system that calculates if the baseline that I'm deploying is actually in line with my budgets, yeah, with what infrastructure should usually cost for a system of my size, or if the predicted cost for my infrastructure is way out of bounds. Yeah. And then I probably need to either approve that myself, like, okay, I know about the risk that this is going to be expensive. I do take on that risk. Yeah. Or I need somebody else to approve, my manager. Or probably I need to kick off an external approval flow in a system like ServiceNow. Yeah. So the orchestrator can wait at certain points very well in the process. And if you think about how usually the workflow with Terraform is, you're a little bit in a plan, approve, apply. land, yeah, then I would try to model it like this. Our system can run a plan stage, and then you would hand over control to ServiceNow to run an approval workflow according to yeah, some metadata that is attached. Yeah, who owns that environment inside of that project? Who's the attached approver? Probably I can get that from ServiceNow. Probably I can get that from a company directory where I can compute the right person and start and initiate that approval workflow. And after the approval has been given, I simply redirect back over a webhook from ServiceNow into the orchestrator, which can then, with the approval, continue into the apply stage. Or just trash the progress and say, okay, this deployment was bombed. Yeah, if the approver was not so keen on actually approving. Yeah, so all of that is totally possible. We are not opinionated on what kind of systems you want to run your approval flows with. If they can integrate on an API or a workflow level, then that is absolutely no problem. Yeah. All right. As we are currently very much in enterprise land, so to speak, if I think about manual approval workflows for these kind of things, let's talk for a second about other infrastructure, or sorry, implementation requirements for enterprises. Like, hey, do I have RBAC? Yes, I do. Memberships here means I am member of a certain organization, I am of a certain role, and that actually describes a baseline set of yeah, capabilities that I'm able to execute inside of the orchestrator. And also, I can constrain that further down to certain projects or environments. I do have service users for automated systems, so the system is fully RBACable and configurable in that sense. And you can also have SSO on top of that, connecting to your most favorite enterprise directories, so you don't need to provision and invite users all day long. All right. I'm not going to dive further into ServiceNow integration. I think this topic is just too specific right now at the moment. If we have time in the Q&A at the end, yeah, we can take a look at that. Um, right. So that is part of our system. What you obviously also want to know is after the fact, what has been done. So the orchestrator keeps a material inventory of all deployments that ever have happened with all of the initiators and all of the outcomes. Um, we do actually enable you to have clean audit logs that can be forwarded to your tracking systems. And we also are able, after every deployment, to update other third-party systems so that you can, for example, have something like a CMDB, which is then reflecting in almost real time what the actual state of your infrastructure is. Do you have any AWS, Azure, or GCP example to show? Oh, you didn't recognize that, right? But that was a GCP example altogether. We just deployed 2 times to GCP. Yeah. And that is the interesting thing here. I, as a developer, do not need to understand deeply where I'm deploying to or how the cloud fabric that I'm deploying to or the fabric of my data center that is provided by departments which do things like DB as a service, or in this case, probably if I was deploying to GCP Cloud SQL, how all of that works. I simply tell the orchestrator, hey, give me a database of type Postgres. And then I will get something that resembles that interface. Yeah. Um, let's hop over to the next example, and then you see something that is more Azure. Um, so over here, I do have prepared an infrastructure in Azure. That's Kubernetes and GCP, right? Yep, exactly. Give me a second. So as you can see, I'm also confident in that stuff here. 1910, our lovely little webinar started at 2000. So 50 minutes before I kicked off the provisioning. That is also fully terraformed, and it takes 6 minutes, 48 seconds to complete. And no, I'm not going to destroy my infrastructure right now. That would probably be not the best idea. Go away. Um, so that has been provisioned and is a completely terraformed infrastructure in Azure. And also all configuration needed for the orchestrator to have some fun deploying with my own infrastructure. All of that is part, going back here, going back here, of the first deployment tutorial where I guided you through the object system of the orchestrator. So if you want to replay what I'm doing here, just go ahead, click on the homepage of Humanitec, the link I want to try it out, and then over here, first deployment tutorial. Probably not 7 minutes. You need to put in some yeah, Terraform variables, a little bit longer, but then you can replay what I'm doing here and dive as deep as you want into the insights and technicalities. All right. So now let's do a few deployments and let's do that a little bit more platform engineer style because up to now I've been working as a developer, so you've not been seeing a lot of the insides of the thing, rather the outside. Okay, so as a platform engineer, I'm probably not going through the CI system. I'm probably trying to build out a new version of some kind of infrastructure provisioning, and I want to test that as quickly as possible. And I'm going to do that using HCTL. We zoom in a little bit here as well, which is our CLI. And I want to deploy, and I want to deploy into this project, which was just provisioned for me. And as I know this is Azure, there's going to be an environment called Azure Dev. Um, and I do also have a slight suspicion that under manifest 2, there is a YAML file that I can use to deploy. Let's look at the help first quickly so you can see a few options. I'm not going to run them all, but you could run a dry run, which is actually just checking on the syntax here, computing the graph and telling you that everything is okay. I could go one step further and run a plan only, executing onto the runner, actually a Terraform plan. That gets me very near to actual provisioning, but stopping right before anything is actually modified. Yeah, and then obviously I could progress one further and say, hey, let's do the actual provisioning, which is what we're going to do right now. I'm not going to skip the logs, but I'm not going to show them either because I guess you all know Terraform logs. They are not that interesting. Yeah. So we are going to do exactly that. System will tell me, hey, your project and your environment, they are existing, but there is no previous stateful deployment. So generating a diff from nothing, we are going to add this demo app. Yes, please do that. Yeah. So it gives me a command I could execute to get to the logs if I wanted to. Yeah, and then it's waiting for the deployment to complete. Hopping over to the orchestrator, I now need to get to my own org, which is called clearcode. In here, I have my tutorial project and my Azure Dev environment. And this is what has been deployed. Something called a score workload, a Postgres database, and both of them living in their own namespaces. And the reason why that happened is because we deployed this manifest file here, which is asking for Postgres DB, asking for a score workload, which is now actually deploying a container. And I'm forwarding the connection string to set PostgreSDB by using the placeholder format into the runtime of that container. I'm not exposing that any further apart from setting up a service here. And that's all I have. So to get to it, I need to quickly go over here and do a kubectl port forward. And where do I want to forward to? So clicking on the score workload, this time I have actually put out some metadata. In this case, this is the namespace where everything is deployed to. So port forward from this namespace, from service demo app, port 8080 local is free, and I know that port 80 is remotely. There we go. Uh, And now I should be able to show you the demo app. As you can see, it, there we go. It refreshes every 5 seconds. That was great. There was the database failure first, and now I'm seeing the table count. So the Postgres cluster did take a little bit longer to provision. Now it's up and configured, so you can see the outcome. And this lovely yellow background color, which is randomly chosen upon deployment. It's auto refreshing every 5 seconds, and that's all I want to say towards this demo app right now. If you see me cut this connection, then this will go dark as soon as the refresh comes. All right, so this has been another deployment to Kubernetes. Yeah. And we're going to now see how different deployments look like. So let me show you another file. And this one is a score file. Yeah. And I think we can agree on the fact that what is here a score workload is exactly the same as what is here a score file, minus the database. I've removed that one so it deploys a little bit faster. Yeah. All right. So, but I think the rest is functionality-wise very equivalent. So let's get to it and actually deploy that one. For score, there's an actual score deploy function. And this time we want to deploy into the score environment and obviously the score.yaml. That looks exactly the same. Shoot, enter, off to the races we are. So while that is deploying, let's take a look at what happened and have a few considerations mentioned. So here, metadata. I could display anything here, not just the things which have been computed as part of the deployment. I could also query third-party systems and integrate that as part of the graph. For example, I could query my FinOps system to actually provide the right data for what this node in the graph is costing me. Yeah, and I could aggregate that up so I can see working up the graph what, for example, the whole deployment, if I click here, costs me, or what different components that I'm deploying do cost me. Or I could display whatever I wanted, like a link to my observability system, which targets the right thing, so I do not need to search if as a developer I click on that. How are you accounting for the case? It's not gradiated yet, since usually gradation means it is production ready. Ha! That is an interesting question. I think, Sean, graduation in this case is simply a thing that is not happening because nobody's really pushing for it. Score is not a product in the sense that it needs to evolve all of the time to stay useful. It is a specification which has been stable from the start. Yeah, so it's not taking on features like mad because it is meant to provide a sensible abstraction. Yeah, and as such, stability is much more important. And that's what it is. And nobody is pushing that heavily. But it is an open source project. So if you think Score should be pushed, do join the project and make a case for graduation. Apart from that, I can safely say that Score is not going to go away. There are enough people interested and actually integrating that into their projects and in their lives. Yeah, but feel free to jump deeper in and take a look at the project. I'm talking about the platform orchestrator here. Score is one of the on routes you can use, but you're not obliged to use it. So choose your own poison. Right. Seeing this graph here, now the question is, what led to this and what led to this here? Yeah, because in the first example, you have seen a service account and a namespace as part of what I was asking for. Here, I didn't ask for it, but still, I got a namespace. So how is that happening? Let's take a look at the module that implements our score deployment. This is what a module definition looks like. And this one here has a dependency on a case namespace. As this is a hard dependency formulated by me here, if it's not yet present, the orchestrator will put it on the graph. Yeah? And that means I, as a developer, do not need to ask for it. If it is needed by the deployment itself will simply put it on the graph. And the orchestrator will manifest it. And as an input for the Terraform run later down the road, it's going to use the namespace name. The module lives under revision control over here. Yeah, I could specify a ref over here to pinpoint a very specific version. And that is the most interesting stuff here. Apart from saying that inputs are inputs, yeah, I can influence them as a platform engineer only. Params are parameters. I can influence them as a developer. Yeah, in this case, for example, the container, I specified that in my score file and that or in my score workload definition. Yeah, and that is the reason why the container that is being deployed is known. So namespace. And there's one more thing to note here, and that are the rules. If I take a look at that, I see there are no constraints over here. If the resource type is score workload, which makes a lot of sense for a score workload, there are no other things typed here. Okay, so there are no constraints. Everybody who asks for a score workload will get this here. Well, everybody? I don't know. This deployment here did take almost 4 minutes, which is something different than the 23 seconds up here. So something different must have happened. But what was it? Let's take a look and find out. So in the projects, back here, I can find my Azure Score environment. Going in here, I see a very different graph. I still have my workload, my score workload, but I do have a VM fleet here. So how did that happen? Well, taking a look at my modules, oh, sorry, let's go to the resource types first. I can see there is my score workload, but as I said, resource types are basically just interfaces. Yeah, I need modules to implement them. Going over to the modules, I can see there's my score K8s module, which is a score workload. But I also have this Ansible score workload, which is a score workload. And taking a look at that one, I can see that it has a dependency on a VM fleet. And taking a look at the rules here, it says, hey, if the environment ID is Azure Score, then this here should match. Well, and as I deployed an Azure Score environment, and this constraint here is triggered, this means this is more specific, it matches more closely, and because of that takes precedent over the more generic match. Now that's the reason why on the second provisioning, I did get a VM fleet and a different outcome because of the rules that I did put into the system as configuration as a platform engineer. So that when I'm wearing my developer hat, I do not need to know about these things. I do not need to think deeply about that. I'm simply saying, hey, deploy my workload into this environment, and the platform takes over and does the needful. So, but what is the outcome? Well, a VM fleet. Okay, so let's hunt that down. As I said, this is an Azure example. So if I go over here and do AZVM list, I can see 3 VMs. Turning that into JSON for a second allows me to show you the time created. And this says 1944, but this is Zulu time. Yeah. So that means those VMs were started 6 minutes ago. So I'm not allowed to cheat here. Because of that, I'm showing you this. And let's take a quick look. AZ accounts list because uh, account lists. Yeah, because I always forget this tenant ID. I don't know why I can't remember this. It's such an easy thing to remember your tenant, right? When you are going to go to the Azure portal and go to the right tenant. Okay. And I need to be the right identity as well, obviously. And that should be, no, uh, this here. So in here, I do have resource groups and there is my VM fleet. So going back here, AZ VM list. The resource group is VM fleet 4727. Okay. VM fleet 4727. So that looks about right. And in here, I do have my 1, 2, 3 virtual machines, including this and whatnot. But more importantly, this load balancer. And that thing has a public IP. And I always make that mistake. If I go to the public IP directly, I can simply copy it without trying to do string manipulation. Hey, which should get me to my demo application right away. And as you can see, that is looking almost the same. Let's change the refresh to 1 second. So it hopefully refreshes faster. You've seen one color change of the background already. We deployed 3 VMs, random background color upon deployment. So you should, with enough changes, enough reloads, the Azure load balancer is sadly not really sticky sessions and not really round robin, but you should see 3 background colors given enough reloads. Yeah. Um, so second time, I basically deployed the same thing. And according to the deployment description or the deployment rules, which were configured into the orchestrator, I did get a radically different outcome. First one was deploy the container into a Kubernetes cluster. Second one was deploy the container into a Docker daemon that is on top of a VM. And for that, first I did take Terraform to provision 3 VMs. That is the VM fleet. And then I used, as the thing is named the Ansible score workload, I used Terraform just as a proxy to start an Ansible run. So using the Ansible playbook provider, I did run an Ansible playbook against all 3 of them. And yeah, configured them because doing that with Terraform is not really nice. Yeah, so using different ISC languages for this kind of job is much better. That's the reason I used Ansible. You can configure VMs very nicely with that thing. Um, that allowed me to put the Docker daemon on top and deploy the container on top of that Docker daemon. Load balancer in front, so I can access all Docker daemons round robin. And that's the outcome that you see here. Antonella also has posted an example of a Lambda function deployment. And with V2, we can safely say that we are not constrained to what we can deploy. Yeah, we can deploy Kubernetes clusters as well as VMs, as you have seen here, as well as serverless functions or any other cloud provider based deployment surface. Yeah, we can also do more wild things. I have things now with customers who do hardware and loop development, where you have some strange machinery sitting on the developer's desk that is connected to his notebook and then needs to get the deployment. Yeah. And those are also scenarios that we can safely cover now with the Orchestrator V2. Right. I hope that was Azure enough as an example for you. I will not dive deeper into the details of how that deployment works. I leave that for you to discover because all of that is available and definitely open source. Yeah. So the first deployment tutorial is existing not only in our documentation, it is also existing in GitHub under an Apache license. Take that and yeah, disassemble it to your heart's content. All of the details are in there. All of the modules that I'm using for deployment are in there. So you can piece that apart completely. Yeah. So this Ansible score workload That's where it lives. Go ahead, check it out. Um, okay, so that basically concludes my whirlwind tour of orchestrator capabilities. I do not have enough time to show you the whole system. It is too broad and too deep, but I hope I've showed you some stuff that is interesting enough to take a deeper look. Yeah. Um, and yeah, if you have any questions for me, if I did miss anything, I'm happy to take that now. Not, I just keep showing you things. No, actually, there's one thing that is probably interesting. If you go to humanitec.com, our well known and beloved website, there is one point which is called use cases. And in here, you will find advanced use cases. Yeah, rollback of applications and infrastructure, staged rollouts, how to understand the blast radius of a deployment before executing it. Um, how do you build something with a developer portal and an orchestrator together? Catch and fix infra drift. Yeah, how do you get drift pinned down, and how do you make that actionable for you? All these advanced scenarios would take too much time to show, but I hope that we have some cool demonstration videos. And if that is not enough, just shoot me a line, yeah, and I'm happy to do a show together with you. Plugins integrations for Backstage. Um, so we have a very defined API, and we had a Backstage plugin in the past, but Backstage portals are a little bit custom for every customer. That is one of their main reasons to be that flexible. Yeah. Um, and we found out that our plugin was used by all and not really fitting for anyone. Yeah. Because we had a very opinionated idea on how people would probably use Backstage together with us, what they would like to see, and it was just not working. And that's the reason why we decided with V2, we are not going to provide a plugin. Instead, we're going to build out a documentation and a CLI that is built to be understood by coding agents. And you should be able, with our API description and a reasonably complex prompt, to let a coding agent build a plugin for you that is getting you to display the information that you actually want, and integrate it into the process that reflects the user journey that you want your developers to have very easily. So that is the idea how we think about Backstage integration with V2. Could you please point this to this Backstage documentation? Um, that's not readable for you. It's readable for an LLM. If you just pick Claude Code and you point it to our own documentation and you hook it up to the Kappa MCP server that we provide, then your coding agent will understand how to integrate us with Backstage. So you don't need to. Okay? But speaking of the devil, I could actually hop over quickly. Um, I think it's under, no, where is it? V2. I always forget that. Integrations, MCP knowledge server. There it is. Yeah. There it lives if you want to integrate your coding agent with our MCP server. So you know a little bit more. So your coding agent knows a little bit more about us. Then this is where you go. Should be very simple setup. And then off to the races you can be. All right. Anything else for tonight? One last question, then I need to go to bed or something like this. And if not, then that was a lovely session. Thanks for listening to my ramblings and staying around and for the good questions. And yeah, I hope you have a wonderful day, evening, night, whatever it is where you are on the planet. And yeah, hope to speak you soon. Haha, there comes the last question. Any certification? Please be more specific. Do I have certifications? Does the orchestrator have certifications? Do you want to make a certification as a platform engineer? I have answers to all of those questions, but which is the one that's interesting to you? Platform engineering. Ha! I can answer that one quite easy. So there is the platformengineering.org community. Yeah. Let me put that link into the chat as well. And in here, there is a link, Get Certified. If you click on that, that leads to, yeah, the home for platform engineering and learning certifications or Platform Engineering University. And there you can become a certified platform engineer. Or you can join the platformengineering.org Slack, and you can find me there under @j and write to me if you like to. All right. I'm going to stop this flicker here. It's driving me mad. Go away. All right. So as promised, that was the last question. Thank you guys. You've been a lovely crowd. Um, have a wonderful day. And yeah, hopefully see you soon.
Thanks everyone